Imagine a world filled with secrets. Not just whispers or hidden letters, but entire civilizations that lived and died, leaving behind puzzles we couldn't even begin to solve. Think about it. How did people build those massive pyramids without modern cranes? What was that strange contraption found in an ancient Greek shipwreck actually for? And what if some of history's biggest questions, the ones that kept scholars scratching their heads for centuries, suddenly had answers? For a long time, understanding the past was like trying to see through a thick fog. We had old texts, broken pottery, and crumbling walls. But often, those pieces didn't tell the full story. Or they told stories we just didn't have the tools to understand. We could guess, we could hypothesize. But solid proof was often out of reach. But then, things changed. We built new machines. We learned to look at things in ways people never could before. We invented technologies that could peek inside solid objects, read faded ink, or analyze tiny bits of ancient dirt. And because of these amazing tools, we started to pierce through that fog. We began to solve mysteries that were, for generations, thought to be unsolvable. It's like science gave us a super-powered magnifying glass and sometimes a time machine. Sometimes it was a tiny fragment of bone. Other times it was a blurred image on an old manuscript. But with new tech, these small clues became huge pieces of evidence. We learned how ancient people died, what they ate, and even who they loved. We figured out what strange artifacts did and how vast structures were built. And we even found traces of entirely forgotten cultures. These weren't just academic wins. They changed how we see human history. They showed us how resilient, how smart, and sometimes how brutal our ancestors were. And it's a wild ride. Here's how some of the biggest ancient puzzles finally got their answers, all thanks to some clever inventions and determined minds. Well, number 17, how did the Iceman Ötzi die, and what was his life like? Ötzi the Iceman is one of the most famous mummies ever found. He was discovered in 1991 by hikers in the Ötztal Alps, right, on the border between Austria and Italy. It wasn't just a skeleton, it was a complete body, remarkably preserved by the ice for over 5,300 years. This wasn't a king or a pharaoh buried with ceremony. This was just a man out in the mountains who died. And his discovery opened up a window into a time we knew very little about. The initial find was almost an accident, and the initial recovery was a bit rough, not realizing the full significance right away. But once he was properly studied, the questions began. Who was he? How did he end up there? And what killed him? Technology has played a huge role in answering these questions. Early examinations quickly showed he wasn't just old, he was ancient. Radiocarbon dating, a technique that measures the decay of carbon-14 isotopes in organic materials, was crucial here. It told us he lived around 3,300 BCE, deep in the Copper Age. This put him much, much older than any other naturally preserved human found in Europe. Researchers like Willard Libby, who pioneered radiocarbon dating, would have been thrilled to see it used on such a treasure. But just knowing his age wasn't enough. People wanted to know about his life. And advanced medical imaging like CT scans and X-rays really helped. Scientists, including Dr. Albert Zink at URAC Research in Italy, conducted extensive CT scans. These scans let them look inside Ötzi's body without damaging it. They saw that he had signs of arthritis, and his teeth were heavily worn, suggesting a coarse diet. They also found evidence of ancient tattoos, a series of simple lines and crosses, possibly for therapeutic reasons, since many of them are located near joints that showed wear and tear. This was one of the earliest examples of tattooing ever found. The biggest mystery was his death. For years, scientists debated if he froze to death, or perhaps fell. But the CT scans revealed something shocking. Deep in his left shoulder, there was an arrowhead. It had entered from behind, piercing a major artery. This was not a natural death, this was murder. And the scans also showed a severe blow to his head, suggesting he was either hit during the attack or fell awkwardly. This changed the whole narrative. Ötzi wasn't just lost in a snowstorm, he was hunted. Then came DNA analysis. Geneticists were able to extract DNA from Ötzi's tissues. This was incredibly difficult because ancient DNA is often degraded. But the team, again including researchers from URAC Research, managed it. His mitochondrial DNA showed he belonged to a rare lineage called K1F. His Y chromosomal DNA indicated he belonged to haplogroup GL91, which is also quite rare in modern Europeans. This suggested his lineage might have largely died out or become very localized. And his DNA also showed he had brown eyes, dark hair, and was lactose intolerant. And even more surprisingly, it showed genetic markers for Lyme disease, making him the earliest known human case. This told us about the health challenges faced by people in the Copper Age. His stomach contents, analyzed using advanced microscopy and DNA analysis of food residues, told us about his last meal. He had eaten dried ibex meat, deer meat, and cereals, specifically einkorn wheat, shortly before his death. This suggests he was probably on a journey, carrying provisions, and pollen analysis from his digestive tract showed he had been in a coniferous forest shortly before he died, helping pinpoint his movements. The tools he carried were also studied with great care. His copper axe, analyzed through metallurgical studies, showed the copper came from Tuscany, far from where he was found. This suggested trade routes or long-distance travel. His quiver held arrows, some unfinished, and a longbow made of yew. His clothing, made from various animal skins, was studied by textile specialists. It was a complex outfit, designed for the harsh mountain environment. Ötzi has been the subject of countless studies, with findings published in journals like Nature Communications and Science. He is held at the South Tyrol Museum of Archaeology in Bolzano, Italy, under very specific conditions to ensure his preservation, a challenging task managed by advanced climate control systems. But even with all this technology, some things remain a mystery. We know he was killed, but we don't know who killed him or why. Was it a personal vendetta, a tribal conflict, a robbery gone wrong? And did he travel from Tuscany with his axe, or was the copper traded? His tattoos, were they truly for pain relief, or did they hold some other cultural or spiritual meaning? And what about the small communities he came from? What were their social structures like? What were their beliefs? The ice preserved his body, but the full story of his people is still lost to time. Number 16. What was the Antikythera Mechanism, and how did it work? Imagine a shipwreck deep in the Aegean Sea. In 1901, sponge divers found one near the island of Antikythera. They brought up statues, pottery, and other treasures, but among them was a corroded lump of bronze and wood. It looked like a rock, or perhaps just junk. Nobody really knew what it was. It wasn't until much later that its true nature began to emerge. This was the Antikythera Mechanism, and for a long time, its purpose was one of the biggest head-scratchers in archaeology. What was this complex gear system doing on a ship from the 1st century BCE? It was far more intricate than anything else known from that period. It defied what we thought ancient Greeks were capable of. For decades, scholars looked at the fragments, trying to make sense of the gears. Early the 10th rays in the 1970s by Professor Derek de Sola Price and Dr. Charalambos Karakalos were a first step. They showed that the lump wasn't just random bits of metal, but an incredibly sophisticated clockwork device. Price published a landmark paper in Scientific American in 1959, suggesting it was an astronomical calculator. But the full picture was still blurry because the machine was so fragmented and encrusted. The real breakthroughs came with much more advanced technology. In the early 2000s, a new research project, the Antikythera Mechanism Research Project, brought together experts from around the world. They used high-resolution X-ray, computed tomography, CT scanning, and a special 3D surface imaging system. Think of a medical CT scanner, but superpowered for archaeology. This tech allowed them to virtually peel back the layers of corrosion and see inside the mechanism without touching it. They could create detailed 3D models of every tiny gear and inscription. Michael Wright, a curator at the Science Museum in London, was instrumental in early reconstructions and analysis using these methods. The CT scans, which generate thousands of X-ray images from different angles, revealed an astonishing level of complexity. They found at least 37 gears, some with incredibly fine teeth, and detailed inscriptions that had been completely unreadable before. These inscriptions, deciphered by researchers like Professor Alexander Jones, turned out to be a kind of user manual describing what the mechanism did. And what it did was astounding. It was an ancient analog computer. It could predict the positions of the sun, moon, and probably the 5 known planets Mercury, Venus, Mars, Jupiter, and Saturn in the sky. It tracked lunar and solar eclipses using a sophisticated gear train to model the moon's irregular orbit. It even had a dial for the Olympic Games cycle, showing which Pan-Hellenic Games were next. This machine was essentially a calendar, an astronomical almanac, and a celestial simulator all rolled into one. It had a main drive handle, which, when turned, would animate all the complex gears showing the celestial ballet. The research was published in journals like Nature and showcased in documentaries, revealing the incredible precision of ancient Greek engineering. The level of miniaturization and complexity was unparalleled for over 1,000 years after its creation. Nothing similar appeared until European clockmaking in the 14th century. It was a device made with a deep understanding of astronomy and mathematics, probably by a skilled craftsman in Rhodes or Corinth, perhaps even influenced by Archimedes or Hipparchus. The ship it was on was probably carrying it as a prize or a valuable piece of equipment. But even with all we know, big questions remain. Was this a unique invention, or were there others like it? No other ancient device of this complexity has ever been found. So, was it an isolated genius's work, or part of a lost tradition of intricate mechanics? We also don't know the exact identity of its creator, and why was such an incredibly valuable and complex device on that particular ship? Was it cargo, or did it belong to someone important on board? The ocean keeps its secrets well, and the Antikythera Mechanism only gave us a glimpse into a lost world of ancient Greek technology. Number 15. How did Neanderthals and modern humans interact, and are we related? For a long time, the story of human evolution was pretty simple. Modern humans, Homo sapiens, came out of Africa and replaced all other hominids like Neanderthals. The idea was that Neanderthals were a separate, primitive species that just died out, unable to compete with our smarter, more adaptable ancestors. We thought of them as brutish cavemen, not really part of our family tree, but that idea was based mostly on skull shapes and stone tools. The truth, revealed by a very specific kind of technology, turned out to be much more complex and surprising. The game changer here was ancient DNA sequencing. In the early 2000s, scientists, especially a team led by Svante Pääbo at the Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany, embarked on an ambitious and incredibly difficult project to sequence the Neanderthal genome. Extracting DNA from bones that are tens of thousands of years old is a monumental task. The DNA is highly degraded, fragmented, and often contaminated with microbial and modern human DNA. They used advanced techniques, including shotgun sequencing and targeted enrichment, to piece together enough genetic material from tiny bone fragments found in places like Vindija Cave in Croatia. Pääbo's group published their first draft of the Neanderthal genome in Science in 2010. This was a massive scientific achievement, and what did that genome reveal? It showed unequivocally that modern humans of non-African descent carry between 1% and 4% Neanderthal DNA. This meant that our ancestors didn't just replace Neanderthals, they interbred with them. There were times, probably around 50,000 to 60,000 years ago, when early modern humans migrating out of Africa met Neanderthals in the Middle East and Europe, and they had children together. This was a profound shift in our understanding of human history. We aren't just one unbroken line. We are a mosaic. Further research, published in journals like Nature and Science, has continued to refine this picture. Scientists have found specific genes inherited from Neanderthals that might have helped modern humans adapt to new environments outside Africa, for example, genes related to immunity or skin and hair traits. But some Neanderthal gene variants might also contribute to conditions like type 2 diabetes or Crohn's disease in modern populations. The technology kept advancing. Pääbo's team, for instance, also sequenced the DNA of another mysterious ancient hominin, the Denisovans, from a tiny finger bone found in a cave in Siberia. And they found that some modern populations in Asia and Oceania carried Denisovan DNA too, indicating multiple episodes of interbreeding between different hominin groups. This work didn't just rely on sequencing machines. It required sophisticated computational biology to assemble these fragmented genomes and statistical methods to compare them to modern human genomes, identifying regions of Neanderthal ancestry. And scientists like David Reich at Harvard Medical School have been central to developing these computational tools, publishing widely on population genetics and ancient admixture events. The implications are huge. It means that the story of human evolution is less like a simple tree branch and more like a braided river, with different streams coming together and flowing apart. Neanderthals weren't a dead end, they are part of us, but with these answers come new questions. How frequent was this interbreeding? Was it a peaceful process or did it happen under duress? What were the social dynamics between these different groups? And why did Neanderthals eventually die out, even with some genetic contributions to our lineage? Was it because of climate change, competition, or simply being absorbed into a larger, expanding Homo sapiens population? We have their DNA in us, but their full story and the complex relationships they had with our direct ancestors is still mostly a blank page. Number 14, how was Göbekli Tepe built, and what was its purpose? Göbekli Tepe in southeastern Turkey is a truly mind-bending archaeological site. For a long time, we thought that monumental architecture, big temples, huge stone structures only came after humans settled down, started farming, and built complex societies. First agriculture, then cities, then temples. That was the accepted order of things. But then Göbekli Tepe came along and completely flipped that idea on its head. When it was first excavated in the mid-1990s by German archaeologist Klaus Schmidt, it was clear this wasn't just another ancient village. It was something else entirely. The site features massive T-shaped stone pillars, some weighing up to 20 tons, arranged in circles. These pillars are intricately carved with images of wild animals, boars, foxes, lions, snakes, birds. It looks like a huge, very old temple complex, but the most shocking thing about it is its age. The crucial technology that helped us understand its age was radiocarbon dating. The samples of organic material found within the layers of construction charcoal from fires, bits of bone clearly were carefully collected and analyzed. These analyses consistently showed that Göbekli Tepe dates back to around 9,600 to 8,200 BCE. To put that in perspective, this is thousands of years before the Egyptian pyramids, before Stonehenge, and even before the widespread adoption of agriculture. It makes Göbekli Tepe the oldest known monumental stone structure in the world. This dating was revolutionary. It showed that hunter-gatherers, people we previously thought were too nomadic and unsophisticated for such projects, were capable of organizing large-scale construction efforts. They moved these massive stones, carved them with incredible skill, and arranged them in complex patterns. This suggested that perhaps communal ritual or religious belief came before settlement and agriculture, not the other way around. People might have gathered for these massive building projects, and then, as a result, started staying in one place and cultivating crops to feed the workforce. Klaus Schmidt, who dedicated his life to this site until his death in 2014, published his findings extensively, often in German archaeological journals and books, but also through articles that reached a wider audience, like those in National Geographic. His work meticulously documented the layers of the site, showing that the older structures were even more massive and intricate than the later ones. They also found that these circular enclosures were intentionally buried over time, perhaps to preserve them or in a ritual act, which contributed to their amazing preservation. Beyond radiocarbon dating, other technologies are being used. Ground-penetrating radar, GPR, and magnetometry have helped survey the site without extensive digging, revealing more circular enclosures still buried beneath the soil. This shows the site is far larger and more complex than what has been excavated so far. Photogrammetry and 3D modeling are also used to create accurate digital representations of the carvings and structures, allowing researchers to study them in detail from anywhere in the world and virtually reconstruct how the site might have looked. The precise carving techniques used on the pillars are still being studied. Microscopic analysis of tool marks can help deduce what kind of stone tools were employed, likely flint and obsidian, and how much effort went into shaping these massive stones. The sheer human power and coordination required to quarry, move, and erect these pillars without draft animals or wheeled transport is staggering. But despite knowing its age and seeing its incredible complexity, the core purpose of Göbekli Tepe is still debated. Was it a temple? A ritual gathering place for different hunter-gatherer groups? A monument to animals? We don't know the specific beliefs or rituals that took place there. What did those intricate animal carvings mean to its creators? Were they symbols of clans, gods, or stories? We don't have any written records from this period, and why was it deliberately buried? Was it because its purpose had been served, or because the beliefs it represented changed? What kind of society was able to organize such a feat without agriculture? These are the questions that continue to puzzle researchers, making Göbekli Tepe one of archaeology's most enigmatic and exciting sites. Number 13, what was the purpose of Stonehenge and where did its massive stones come from? Stonehenge, that iconic circle of standing stones on Salisbury Plain in England, has fascinated people for centuries. It's an imposing, mysterious monument, and the questions have always been the same: who built it? How did they move those gigantic stones? And why? For a long time, its purpose was pure speculation, ranging from a druid temple to an alien landing site. The sheer scale of the blue stones and saracens, some weighing up to 40 tons, begged for an explanation. Early archaeologists like William Stukeley and later William Cunnington and Richard Colt Hoare did much of the initial mapping and excavation, but without modern tools, they were limited. They could observe, but not deeply analyze. The first major technological breakthrough was radiocarbon dating. In the mid-20th century, this method started giving real dates to the various phases of Stonehenge's construction. It showed that the earliest earthworks date back to around 3000 BCE, and the famous stone circles were erected between 2500 and 2000 BCE. This placed its construction firmly in the late Neolithic and early Bronze Age, long before the Druids. This was a critical step in dispelling many myths and focusing research on the true builders, prehistoric farmers, and herders. Professor Mike Parker Pearson from University College London has led extensive research projects, including the Stonehenge Riverside Project, which used dating methods to establish the chronology. But knowing when wasn't the same as knowing how or why. The how of moving the stones was still baffling. The larger saracens come from Marlborough Downs, about 20 miles north. That's a huge undertaking. But the smaller blue stones, which weigh up to 4 tons, presented an even greater puzzle their source. The solution came from geological science, specifically petrography and geochemistry. So researchers like Herbert Thomas opened the door, but modern methods refined it. In the 2000s, studies, particularly by Dr. Richard Bevans and Professor Nick Pearce from the National Museum of Wales and Aberystwyth University, used techniques like X-ray fluorescence and mass spectrometry. They analyzed the chemical composition of the bluestone fragments at Stonehenge and compared them to rock samples from potential sources in Western Wales. The results were a stunning match. The bluestones came from the Preseli Hills in Pembrokeshire, Wales, over 140 miles away. Even more specifically, some came from Carngoedog and others from Craig Rossi Felon. This was a monumental effort. It meant these stones were either dragged overland, rolled on logs, or floated on rafts across the Bristol Channel. The logistical organization required was immense, suggesting a highly coordinated society. This research, published in journals like Antiquity and Archaeology in Wales, confirmed a truly epic feat of prehistoric engineering. As for why technology is also shedding new light, beyond the stones themselves, technologies like ground-penetrating radar GPR, magnetometry, and LiDAR light detection and ranging have been used to survey the wider Stonehenge landscape. Projects like the Stonehenge Hidden Landscapes Project, led by Professor Vince Gaffney, have used these remote sensing methods to map hundreds of previously unknown archaeological features, including barrows, shrines, and pits, without even touching the soil. They found a vast network of prehistoric activity. This suggests Stonehenge wasn't an isolated monument, but part of a much larger ritual landscape. These surveys revealed alignments that strongly suggest astronomical observations. Solstices, equinoxes were key. Stonehenge functioned as a sophisticated calendar, marking the changing seasons, which was critical for an agricultural society. It may also have been a place of healing, with the bluestones having perceived medicinal properties, as their source in Wales was also associated with springs. So, while we have answers about its age and the origin of its stones, many questions still linger. How exactly did they transport those Welsh bluestones across 140 miles of rough terrain and sea? Were they brought by boat or overland? We have theories, but no definitive proof of the method. What were the specific beliefs and rituals that took place there? We know it was astronomically aligned, but what was the deeper spiritual meaning? And what happened to the people who built it? Did their society collapse, or did their beliefs change, leading to the abandonment of this incredible monument? The stones stand silent, holding many stories we still cannot read. Number 12. What caused the collapse of the classic Maya civilization? The classic Maya civilization, which flourished in what is now southern Mexico and Central America between about 250 and 900 CE, was incredibly advanced. They built massive cities with pyramids, temples, and palaces. They developed a complex writing system, sophisticated mathematics, and highly accurate astronomical calendars. But then, around the 9th century CE, something went terribly wrong. Many of their great cities in the southern lowlands, like Tikal and Palenque, were abandoned. Construction stopped, populations dwindled, and the elaborate political system dissolved. For a long time, this classic Maya collapse was one of archaeology's most enduring mysteries. Was it war, disease, invasion, or something else entirely? For many years, archaeologists debated fiercely, often without definitive evidence. Early theories often focused on warfare or internal political strife, based on interpretations of hieroglyphic texts and archaeological evidence of conflict. But these didn't fully explain the widespread, synchronous nature of the decline across such a large area. The major breakthrough came from environmental science and advanced climate modeling powered by geological data. Scientists started looking beyond human actions and focusing on the natural environment. One key technology has been paleoclimatology, the study of past climates. Researchers have extracted core samples from lake beds, like those in Lake Chichancanab and Punta Laguna in the Yucatan Peninsula. These sediment cores contain layers of geological and biological material like pollen, charcoal, and isotopes of oxygen and carbon that act as a natural archive of past environmental conditions. By analyzing these cores, scientists, including those at institutions like the University of Florida and the University of Cambridge, found compelling evidence of severe, prolonged droughts during the late Classic period, specifically between 800 and 1000 CE. For example, in 2018, a study published in Science by Nicholas Evans and others used a method called clumped isotope analysis on gypsum, a mineral that forms during droughts in lake beds. This analysis showed that rainfall decreased by 50 to 70% during the peak of the Maya collapse. This wasn't just a single dry year. These were multi-decade megadroughts that would have devastated an agricultural society dependent on rainfall for their crops, especially maize. The sophisticated Maya water management systems, while impressive, simply couldn't cope with such extreme and sustained aridity. Another crucial technology has been LiDAR, light detection and ranging. Mounted on aircraft, LiDAR penetrates dense jungle canopy using laser pulses to map the ground beneath. This technology, used extensively by projects like Pacunum, has revealed thousands of previously unknown Maya structures, including entire cities, agricultural terraces, and vast networks of causeways. This showed that the Maya population was much larger and more widespread than previously thought, numbering in the tens of millions. This larger population would have put immense pressure on land and resources, making them even more vulnerable to climate shocks. The sheer scale of their settlements, uncovered by LiDAR, suggested extensive deforestation to clear land for agriculture and provide fuel and building materials. This deforestation could have exacerbated the droughts, creating a feedback loop where less forest meant less moisture retention and hotter local temperatures. Researchers like Professor E. Willis Andrews V from Tulane University and Dr. Richard Hansen, who works at El Mirador, have used LiDAR to understand the scale of the Maya world, showing its vastness and the implications for resource use. So the technological evidence points to a complex interplay of factors: massive population growth, environmental degradation, deforestation, and then a series of devastating prolonged droughts. The climate change theory, backed by solid scientific data, is now the leading explanation for the collapse of the southern lowland cities. But even with this strong evidence, we still have questions. Why did some Maya cities in the northern Yucatan survive and even flourish for centuries after the collapse in the south? Did their different, water management strategies or ecological conditions play a role? How did the political and social structures contribute to their vulnerability? Did the elites make poor decisions in the face of environmental stress, perhaps continuing to demand resources for monumental construction when basic food supplies were dwindling? And what was the human cost of this collapse? We have evidence of abandonment, but the specifics of suffering, migration, and the breakdown of society are still largely unseen. The story is clearer, but many chapters are still unwritten. Number 11. What was the purpose of the Roman concrete and why was it so durable? The Roman Empire was famous for its engineering feats. They built massive aqueducts, huge domes like the Pantheon, and extensive road networks, many of which are still standing today, almost 2,000 years later. Their secret ingredient, it seemed, was concrete, but this wasn't modern concrete. It was a unique mixture. And for a long time, scientists didn't fully understand why it was so incredibly durable especially in harsh environments like seawater. But modern concrete often cracks and degrades over centuries, but Roman concrete structures submerged in the ocean have remained intact. What was their trick? For a long time, scientists knew that Roman concrete, called opus caementicium, involved volcanic ash, particularly from the Pozzuoli region near Naples known as Pozzolana. Vitruvius, the Roman architect and engineer, wrote about it in his 1st century BCE treatise, De Architectura. He described mixing lime and volcanic sand, but understanding the exact chemical reactions and microstructural properties that gave it such strength and longevity required advanced material science techniques. The real answers started coming from researchers in the early 2000s, like Professor Marie Jackson, a research engineer and geologist at the University of Utah. She and her colleagues have spent years studying samples of ancient Roman concrete from marine structures, harbor walls, and inland buildings. They used a battery of high-tech analytical tools. One key technology was scanning electron microscopy (SEM) coupled with energy dispersive X-ray spectroscopy (EDS). SEM allows scientists to magnify samples thousands of times, revealing the intricate microstructure of the concrete. EDS helps determine the elemental composition of different phases within the material. These techniques showed that the Roman concrete wasn't just a simple mix. It formed incredibly stable and durable mineral phases over time. Another crucial technique was X-ray diffraction (XRD). XRD helps identify the crystalline structures of minerals within a material. This revealed the presence of specific compounds like tobermorite and philipsite that formed when the volcanic ash reacted with seawater and lime. These minerals have a unique platy structure that makes the concrete incredibly resilient. Perhaps the most astonishing discovery, published in journals like American Mineralogist and Nature Materials, was that Roman concrete isn't just passively durable, it actually self-heals. Professor Jackson's team found that in contact with seawater, the concrete continues to react and grow new minerals over time. When cracks appear, these minerals crystallize within the cracks, filling them in and strengthening the structure. This is a truly remarkable property, something modern concrete engineers are still trying to emulate. The combination of volcanic ash, lime, and seawater creates a chemical reaction that effectively allows the concrete to repair itself. The research also highlighted the importance of aluminum tobermorite, a rare hydrothermal mineral that forms slowly over centuries. This mineral, along with the very specific pozzolanic volcanic ash rich in potassium and aluminum, appears to be the key to its unique strength and durability, particularly in marine environments where other concretes would quickly degrade. This technological analysis has completely changed our understanding of Roman engineering. It shows they weren't just skilled builders, but also, perhaps intuitively, master chemists. They understood their materials deeply, even if they couldn't explain the chemistry at a molecular level. But even with this incredible understanding, some questions persist. Could we truly replicate Roman concrete today? We know the ingredients and the general process, but the long-term formation of these specific minerals over centuries is hard to rush. And the exact type of volcanic ash they used from Pozzuoli had specific properties that are not easily found everywhere. Would modern large-scale production be economically viable, given the slow curing process? And beyond the physical properties, what kind of empirical knowledge did the Roman engineers use to select and mix these materials so perfectly? Was it purely trial and error over generations, or did they have some theoretical framework we've lost? The secrets of their practical wisdom might still be hidden from us. Number 10. How were the terracotta army statues originally painted, and what did they really look like? When the terracotta army was discovered in 1974 near Xi'an, China, it was an archaeological sensation. Thousands of life-size terracotta warriors and horses arranged in battle formation guarding the tomb of China's first emperor, Qin Shi Huang, who died in 210 BCE. The scale was breathtaking, but the warriors, as we usually see them in photos, are earthy gray and brown. They look like statues made of clay, which they are. For a long time, people assumed they were always this color, perhaps meant to evoke the raw earth from which they came. But that wasn't the full story. Early excavations often found traces of color, but they quickly faded and flaked off once exposed to air. The vibrant original appearance was a mystery. How could we understand the true artistry and the visual impact of this incredible army if we didn't know how it was originally painted? The challenge was that the paint layers were incredibly thin, fragile, and chemically unstable. They degraded rapidly upon exposure to light, changes in humidity, and particularly the drying air after centuries in the damp earth. This rapid degradation meant that archaeologists had only fleeting glimpses of the original colors. The solution came from cutting-edge conservation science and advanced imaging techniques. Researchers, particularly at the Bavarian State Department of Monuments and Sites and the Qinshi Mausoleum Site Museum in Xi'an, began using sophisticated methods to stabilize and analyze the fragile paint layers in situ and on carefully extracted fragments. One key technology was multispectral imaging. This technique uses different wavelengths of light, including ultraviolet and infrared, to reveal pigments that are invisible to the naked eye or to differentiate between layers. Coupled with microscopic analysis, this allowed conservators to identify the exact colors and even the order of the paint layers. Another critical technology was X-ray fluorescence XRF spectroscopy. XRF is a non-destructive analytical technique that can identify the elemental composition of materials. By analyzing the pigments, XRF revealed that the ancient Chinese used a wide range of mineral pigments: cinnabar for red, azurite for blue, malachite for green, and lead white for white. They also used a unique pigment called Han purple barium copper silicate, which was an artificial pigment, a remarkable technological achievement for the time. This finding was a major discovery, demonstrating their sophisticated understanding of materials science. The research, published in journals like Accounts of Chemical Research and Journal of Archaeological Science, confirmed that the terracotta warriors were not drab at all. They were incredibly vibrant. Each warrior was individually painted with different colored robes, armor details, and even distinct facial features, making them look remarkably lifelike. Imagine thousands of brightly colored warriors standing in formation, each with a unique face. The sight would have been dazzling and terrifying. These technologies not only identified the pigments, but also helped understand the original binding medium, which was found to be a lacquer from the sap of the lacquer tree. This lacquer provided a smooth, durable surface for the pigments. The rapid deterioration of this lacquer layer upon excavation was a major problem, as it caused the paint to flake off. This understanding led to the development of new conservation strategies, including using polyethylene glycol and other polymers to stabilize the lacquer and paint layers before and during excavation. Thanks to this technology, conservation efforts now focus on immediate stabilization, sometimes even involving micro-excavation directly around the paint to preserve it. This allows for detailed documentation before the paint degrades. But even with these incredible revelations, some mysteries remain. How did they mass-produce these individual paint schemes with such consistency and artistic quality? Was there a factory system? What were the specific ritual or symbolic meanings of certain colors for the Qin dynasty? We have evidence of the splendor, but the full cultural context and the exact aesthetic principles they followed are still not fully understood. And despite our best efforts, the original colors are still extremely difficult to preserve perfectly once exposed to the modern environment, so most warriors we see today remain without their original vibrant coats. The ghost of their true appearance is clearer, but not quite fully present. And number 9, what happens to the people of Pompeii and Herculaneum in their final moments? The eruption of Mount Vesuvius in 79 CE was one of the most catastrophic natural disasters in history. It buried the Roman cities of Pompeii and Herculaneum under layers of ash and pumice. For centuries, these cities were forgotten, perfectly preserved like a time capsule. When they were rediscovered and excavated, they offered an unparalleled glimpse into daily Roman life. But one of the most haunting questions was about the people themselves. What happened to them? How did they die and what were their final moments like? Like early excavations famously led by Giuseppe Fiorelli in the 19th century made a poignant discovery. They found hollow voids in the solidified ash where human bodies had once been. Fiorelli developed a technique to pour plaster into these voids, creating eerie, lifelike casts of the victims. These casts, showing people in their final postures, clutching loved ones or shielding their faces, were incredibly moving. But while they showed the form of their deaths, they didn't fully explain the mechanism. Were they suffocated by ash? Burned by lava? What was the true horror of those last minutes? The real answers began to emerge with modern medical imaging technology, especially CT scans and advanced forensic anthropology. In 2015, a major project, led by archaeologists like Massimo Ossana, the superintendent of Pompeii, involved using state-of-the-art CT scanners to analyze the plaster casts and the human remains within them. This was groundbreaking because it allowed scientists to see inside the casts, revealing the skeletal remains and even dental details without damaging the precious plaster. The CT scans provided a wealth of information. They showed that many victims, particularly in Pompeii, had died from asphyxiation due to inhaling fine ash and toxic gases. The plaster casts, in many cases, contained perfectly preserved skeletons, and the scans revealed their bones and teeth in incredible detail. For instance, dental analysis showed surprisingly good oral health for many, likely due to a diet low in sugar. Bone analysis could reveal details about their age, sex, and even health conditions like arthritis or fractures. However, the story in Herculaneum was different and even more horrific. Herculaneum was closer to Vesuvius and was hit by pyroclastic flows, superheated clouds of gas, and volcanic debris moving at hundreds of miles per hour. Early excavations found skeletons, but they were often found in boathouses, having apparently sought refuge. Later forensic studies, particularly those by Dr. Pier Paolo Petroni from the University of Naples Federico II, used advanced techniques like high-temperature micro-CT scanning and chemical analysis on the bone fragments. What they discovered, published in journals like PLOS ONE and Antiquity, was truly shocking. The victims in Herculaneum didn't die from asphyxiation, they were flash-heated. The pyroclastic flows were so hot over 500 degrees Celsius that their soft tissues vaporized almost instantly. Their skulls literally exploded and their brains were boiled. The sudden extreme heat also caused their bones to fracture. In one particularly gruesome find, a black glassy material was found inside a skull, which forensic scientists identified as vitrified brain-matter-brain tissue that had been superheated and then rapidly cooled into a glass-like substance. This was direct evidence of instant vaporization of tissues. These technological analyses painted a much clearer and more terrifying picture of the different ways people died. In Pompeii, a slower, agonizing death by suffocation. In Herculaneum, an instantaneous, brutal incineration. Further analysis of strontium isotopes in teeth allowed researchers to determine where some individuals grew up, indicating migratory patterns within the Roman Empire. DNA analysis, though more challenging due to the heat damage, is also slowly yielding information about genetic relationships between individuals and populations. But despite these incredible insights, many questions remain. We have these snapshots of death, but what were the people's lives like moments before? What were their thoughts, their fears? Who are the specific individuals behind these haunting casts and skeletons? While we can determine age and sex, their names, relationships, and personal stories are largely lost. And how many people truly died across the entire affected region? We've only uncovered a fraction of the buried cities. The human tragedy of Vesuvius is clear, but the individual stories remain shrouded in ash. Number 8. What was the purpose of the Nazca lines and who created them? The Nazca lines, etched into the arid plains of Peru, are one of the world's most impressive and mysterious archaeological sites. These massive geoglyphs depicting animals like hummingbirds, monkeys, spiders, and even human-like figures, as well as geometric shapes, are so huge that they can only be fully appreciated from the air. For decades, their scale and location on a high, dry plateau led to all sorts of wild theories, including ideas about alien visitors. The fundamental questions were who made them, how did they make them so precisely, and why. For early researchers like Paul Kosak and later Maria Ricci spent decades mapping and studying the lines from the ground, painstakingly measuring and drawing them. Ricci, a German mathematician, was instrumental in recognizing their astronomical alignments. But studying something that stretches for miles from the ground is incredibly difficult. The real understanding of the Nazca lines came with the advent of aerial photography and satellite imagery. In the mid-20th century, aerial surveys started revealing the true extent and complexity of the geoglyphs. Today, high-resolution satellite imagery, combined with drones and advanced photogrammetry, allows archaeologists to map the entire Nazca Pampa with unprecedented detail. Projects by researchers like Professor Johann Reinhard of National Geographic and more recently Professor Masato Sakai of Yamagata University in Japan have extensively used these technologies. These remote sensing technologies didn't just show what was there, they helped understand the context. They revealed settlements, paths, and other archaeological features surrounding the lines. This immediately dispelled the alien theories. The lines were clearly made by the Nazca people who flourished in the region between 200 BCE and 600 CE. The method of creation was also understood. The Nazca removed the reddish-brown top layer of oxidized rocks, exposing the lighter-colored soil beneath. Because the region is one of the driest places on Earth with almost no wind, the lines have been preserved for centuries. But the why was still a puzzle. Satellite imagery and drone mapping helped link the lines to potential water sources and ritual practices. For example, some geoglyphs seem to point towards sources of water, which would have been incredibly important in such an arid region. The animals depicted, like hummingbirds associated with fertility and water in many cultures, spiders associated with rain, and monkeys often linked to water sources in the Amazon, reinforced the idea that these lines were connected to water cults and fertility rituals. Advanced surveying techniques, including GPS and total stations, allowed researchers to recreate the Nazca's geometric methods. They likely used simple tools like ropes, stakes, and possibly astronomical observations to create the incredibly precise straight lines and perfect circles, often replicating smaller designs on a massive scale. The accuracy is remarkable, suggesting a sophisticated understanding of geometry and measurement. Professor Sakai's work, often published in academic journals and highlighted by UNESCO, has identified hundreds of new geoglyphs using drone imagery and AI analysis, even finding different styles and periods of line creation. Some of these newly discovered lines are smaller and older, suggesting the practice evolved over time. The use of AI to analyze aerial images helps to quickly identify patterns and anomalies that human eyes might miss, significantly speeding up the discovery process. So, technology firmly attributed the Nazca lines to the Nazca people and provided strong evidence that they were ceremonial or ritualistic, likely related to water, fertility, and communication with deities. They were prayers etched into the earth, yet despite these answers, deep questions remain. What were the specific rituals performed at the lines? Were they walked upon? Were offerings made? We found very little direct archaeological evidence at the lines themselves. What was the exact meaning of each specific animal or geometric symbol? Did different clans or communities create different types of lines? And what happened to the Nazca civilization itself? While not as abrupt as the Maya collapse, the Nazca also declined, possibly due to environmental changes or resource mismanagement. The lines tell us about their beliefs, but not the full story of their rise and fall. Number 7. How did the Vikings reach North America, and when? For centuries, the story of European arrival in the Americas began with Christopher Columbus in 1492. It was a well-established fact taught in schools around the world. But then, Saga's ancient Norse tales spoke of Viking voyages to a land called Vinland, west of Greenland. Were these just myths, or did the Vikings really make it across the Atlantic long before Columbus? The sagas described a place with grapes, timber, and encounters with native peoples, but they lacked specific geographical details or archaeological proof. The breakthrough came in the 1960s with the archaeological discovery at L'Anseaux Meadows on the northern tip of Newfoundland, Canada. Norwegian explorer Helge Ingstad and his archaeologist wife Anne Stein, Ingstad began excavating mounds that looked suspiciously like the remains of Norse longhouses. Initial excavations uncovered structural remains, iron rivets, and characteristic Norse artifacts, like a spindle whorl and a bronze pin, indicating textile production, which was typically done by women in Norse settlements. But simply finding Norse artifacts didn't give a precise date. The crucial piece of technology that firmly placed the Viking presence in North America centuries before Columbus was radiocarbon dating. Organic materials found at the site charcoal from hearths, wood fragments, and turf from the walls of the structure's piece were carefully collected and sent for analysis. Radiocarbon dating, which measures the decay of carbon-14 isotopes, provided the definitive proof. The results consistently dated the occupation of L'Anseaux Meadows to around 1000 CE. This date was a game changer. It showed that Vikings had indeed established a settlement in North America, roughly 500 years before Columbus set sail. This finding was published and widely recognized, leading to L'Anseaux Meadows being declared a UNESCO World Heritage Site. More recently, even more precise dating techniques have refined this timeline. In 2021, a study published in Nature by Michael D. and his colleagues used a new method of radiocarbon dating that leverages a cosmic ray event. A massive solar storm in 992 CE produced a distinct sharp spike in atmospheric carbon-14 levels, which was then absorbed by trees. By finding wood samples from Olanse meadows that contained this specific carbon-14 signature and counting the tree rings from that specific year, they could precisely date the felling of the trees used for construction to exactly 1021 CE. This provided the earliest definitive date for Europeans in the Americas. Beyond dating, other technologies have helped. Metallurgical analysis of the iron slag found at the site confirmed that the Vikings were processing bog iron into usable metal. This was a critical finding because Native Americans in the region did not smelt iron. Our geochemical analysis of the artifacts helps link them to Norse origin, and even DNA analysis of ancient plant remains found in the soil can shed light on the local flora and fauna the Vikings encountered. The archaeological and technological evidence thus confirmed that the sagas, though perhaps embellished, were rooted in historical fact. The Vikings were the first Europeans to cross the Atlantic and establish a foothold in the New World. But even with this definitive answer, new questions arise. Why was the settlement at Lansos Meadows so short-lived? The sagas mention conflicts with native peoples whom they called Skraelings and challenges with resources. Was it simply too difficult to maintain a permanent settlement so far from their Greenland and Icelandic bases? We don't have a clear picture of the specific interactions, peaceful or violent, between the Vikings and the indigenous peoples of North America. What routes did they take along the North American coast, and did their presence have any lasting impact on the indigenous populations, perhaps through trade or the spread of disease, even after the settlement was abandoned? The exact reasons for their withdrawal remain debated, and the full extent of their exploration is still unknown. Number 6. What was the purpose of the elaborate burials of the Siberian Ice Maiden, Princess Yukak? In 1993, archaeologists working in the remote Altai Mountains of Siberia near the Yukak Plateau made an extraordinary discovery. Buried deep in a Kurgan burial mound was the perfectly preserved body of a young woman, along with 6 horses adorned with elaborate gear. The ground was permafrost, which had acted like a natural freezer for over 2,500 years. She became known as the Ice Maiden, or Princess Yukak. Her clothes, her intricate hairstyle, her wooden pillow, and especially her extensive tattoos were all remarkably preserved. This was a direct window into the Pazyryk culture, a nomadic Iron Age people, known for their elaborate burial practices. But who was this woman? Why was she buried with such pomp and circumstance? And what did her tattoos mean? The preservation by permafrost was key, but technology was needed to study her without damaging her fragile remains. Initial examinations and subsequent detailed studies employed a range of non-invasive and minimally invasive techniques. One of the first challenges was to determine her age and exact time period. The radiocarbon dating of organic materials found in the tomb, such as wood, textiles, and parts of the horses, placed her burial at around 500 to 300 BCE. This confirms she was from the Pazyryk culture, a Scythian-related group known for their distinctive art and nomadic lifestyle. Natalia Polazmak, the lead archaeologist on the excavation, published extensively on the find, highlighting the cultural significance. Then came the detailed medical and forensic analysis. MRI scans, magnetic resonance imaging, were crucial. An MRI allows scientists to see soft tissues in great detail without disturbing the body. These scans revealed details about her internal organs, her bone structure, and even signs of illness. The scans showed she likely suffered from breast cancer, with evidence of metastasis to her bones, and was in considerable pain in her final months. She also showed evidence of osteomyelitis, a bone infection. This information, published in scientific reports, shed light on the health challenges and medical knowledge, or lack thereof, of the Pazyryk people. Perhaps the most striking aspect of the Ice Maiden was her tattoos. Her skin was covered in elaborate swirling designs depicting mythological creatures: a deer with griffin's heads on its antlers, a ram, a leopard. These were incredibly complex and beautifully rendered. To study these without damaging the skin, researchers used infrared photography and digital enhancement. Infrared light can penetrate the skin to reveal pigments beneath the surface or to enhance faded designs. This allowed for detailed mapping and reproduction of the tattoos, revealing their full artistic and symbolic complexity. These images have been widely published, showcasing the incredible artistry of the Pazyryk. Her horses were also studied using a range of technologies. Analysis of their teeth and bones provided insights into their diet, age, and breeding. The elaborate saddlery and decorations, made of wood, felt, and leather, were also preserved, and their construction techniques were analyzed by textile and material specialists. All this evidence points to her being a person of very high status, possibly a priestess, a shaman, or a clan leader. The elaborate burial, the rich grave goods, the horses, and the complex tattoos all suggest a significant spiritual or political role within her community. The discovery challenged the view of nomadic Iron Age societies as simple, showing a rich spiritual and artistic culture. But even with these incredible revelations, many questions still surround the Ice Maiden. What were the specific beliefs of the Pazyric culture that these tattoos and burial rituals represented? Did the tattoos have magical, protective, or social meanings beyond simple decoration? We know she was likely ill, but did her community try to treat her, and if so, how? And why was she buried on a remote plateau in such an elaborate manner, rather than in a more central location? Her story, while technologically unveiled in many details, still has an aura of deep ancient mystery about the specific spiritual and social roles she fulfilled. Number 5. How old is the Giant of Cerne Abbas, and why was it made? The Cerne Abbas giant is a massive hill figure carved into the chalk hillside near the village of Cerne Abbas in Dorset, England. It depicts a naked, erect male figure, 180 feet, 55 meters tall, wielding a club. For centuries, its age and origin were a complete mystery. Local folklore attributed it to ancient Celtic gods or Roman Hercules. Some historians thought it might be a much later creation, perhaps from the 17th century, a satirical depiction of Oliver Cromwell. Without any written records or archaeological context, it was impossible to say for sure. Its purpose also remained highly speculative. Was it a fertility symbol? A protector? A god? The challenge in dating the giant was that it's just an outline cut into the turf, revealing the chalk beneath. There are no associated artifacts or structures for traditional archaeological dating methods. For years, theories were based on artistic style comparisons or historical documents that didn't directly mention the giant. The breakthrough came with optically stimulated luminescence OSL dating. This is a powerful geological dating technique that can determine when sediment was last exposed to sunlight. In 2020, a project led by the National Trust and the University of Wales Trinity St. David, with archaeologist Martin Patworth, collected samples of soil from the deepest layers of the giant's elbows and feet. OSL dating works by measuring the amount of energy trapped in mineral grains, like quartz or feldspar in the soil. When these grains are exposed to sunlight, the trapped energy is released. Once buried, the energy starts to accumulate again from background radiation. By measuring this accumulated energy, scientists can calculate how long it has been since the sediment was last exposed to light. The results published in the journal Antiquity were surprising and definitive. The OSL dating showed that the giant was likely created in the late Saxon period, around 700 to 1100 CE. This completely ruled out both the prehistoric and Roman theories, as well as the 17th century hypothesis. Placed the giant firmly in the early medieval period, a time when England was transitioning from Anglo-Saxon kingdoms to a unified nation, and Christianity was becoming dominant. This was a period we knew little about in terms of monumental artwork. The date was much later than many expected. Before this, the earliest clear reference to the giant was in a church record from 1694. The OSL dating moved its creation back by at least 600 years. This meant that the figure survived centuries of Christian influence and local changes. Other related technologies like geophysical surveys using ground-penetrating radar have been used to map the giant's outline and any potential associated features without disturbing the ground. This helps conservators understand how to maintain the figure, which needs regular recutting to prevent it from disappearing as the turf grows back. So, OSL dating definitively answered when the giant was made, and by whom's the Anglo-Saxons, not the Celts or Romans. This changes the context entirely, but even with the age pinned down, the why is still very much a puzzle. Why would a community in early medieval England carve such a blatant pagan fertility symbol in a landscape that was increasingly Christian? Was it a form of resistance, a fusion of older beliefs with new ones? Was it related to specific local pagan cults that persisted? The Anglo-Saxons left written records, but none mention this giant. What was its function in their society? Was it a territorial marker, a deity, a representation of a folk hero, or something else entirely? The giant's impressive form still gazes out over the Dorset hills. And while we know his age, his full story and specific meaning remain shrouded in the mysteries of the Anglo-Saxon mind. Number 4. How was the Ulu Barun shipwreck cargo used, and where did it all come from? The Ulu Barun shipwreck, discovered in 1982 off the coast of Turkey, is often called the greatest shipwreck ever found. It dates to the Late Bronze Age, around 1300 BCE, a time of immense trade and interaction across the Mediterranean. The ship, likely a merchant vessel, was carrying an astonishing cargo of copper and tin ingots, exotic wood, ivory, pottery, jewels, and luxury goods from at least 7 different cultures. For archaeologists, it was a time capsule offering a direct look into the vast trading networks of the Bronze Age. But the sheer diversity and quantity of the cargo raised immediate questions. Where did all these goods originate? Who was trading what with whom? And what did this complex web of exchange reveal about the interconnectedness of ancient civilizations? For over a decade, a team led by George Bass and Samuel Pulak of the Institute of Nautical Archaeology INA meticulously excavated the shipwreck, bringing up thousands of artifacts from a depth of 140 to 170 feet, 43 to 52 meters. Manual excavation was critical, but the subsequent analysis of the cargo relied heavily on advanced scientific techniques. One of the most important technological applications was elemental and isotopic analysis of the metals. The ship carried 10 tons of copper ingots and 1 ton of tin ingots, the basic ingredients for bronze. Using techniques like X-ray fluorescence XRF and lead isotope analysis, researchers could trace the origin of these metals. Lead isotope analysis, pioneered in archaeology by people like Noel Gale and Zofia Stos-Gale, compares the unique fingerprint of lead isotopes in an artifact to geological samples from known ore deposits. This is a precise way to pinpoint geographical origin. The findings, published in numerous academic articles by the INA team, revealed that the copper came primarily from Cyprus, a major Bronze Age copper producer. The tin, surprisingly, came from as far away as Central Asia, modern-day Afghanistan, and Uzbekistan, which meant a vast overland trade network had to exist to get the tin to the Mediterranean. This was a crucial piece of evidence demonstrating the truly globalized nature of Bronze Age trade. Other artifacts also underwent scientific scrutiny. Ivory, carved into cosmetic boxes and musical instruments, was identified as elephant and hippopotamus ivory through microscopic analysis of its structure, tracing it to regions like Syria, Egypt, and Nubia. Wood samples, including logs of African blackwood, were identified through dendrochronology, tree ring dating, and wood identification techniques, linking them to specific regions. Glass ingots, some of the earliest known glass, were analyzed for their chemical composition to determine their likely place of manufacture, possibly Egypt or Mesopotamia. The vast collection of pottery was also a technological marvel to analyze. Ceramic petrography, microscopic analysis of thin sections of pottery, and neutron activation analysis NDW, which identifies trace elements in clay, were used to pinpoint the geographical origin of different vessel types. This revealed pottery from Mycenaean Greece, Syria, Palestine, Cyprus, and Egypt, showing a truly international merchant ship. Dr. Elizabeth Carter and Dr. Christopher Pulak, among others, were key in the pottery analysis. The sheer scale of this interdisciplinary research, combining archaeology, chemistry, geology, and material science, fundamentally reshaped our understanding of late Bronze Age economies and international relations. It showed that kingdoms across the Near East and Aegean were deeply interdependent, exchanging raw materials and finished goods on an industrial scale. But even with this unprecedented view into Bronze Age trade, questions persist. What was the exact nationality of the ship and its crew? While the cargo was diverse, the ship itself might have been Canaanite Syro-Palestinian, based on some artifacts. Who was the ultimate patron or owner of this vast cargo? Was it a royal shipment, a private merchant, or a state enterprise? We don't have a manifest or a bill of lading. And what was the exact destination? Was it Egypt, a Mycenaean palace, or somewhere else? The ship sank, so its final port of call remains unknown, leaving us to wonder about the intended recipients of its magnificent bounty. Number 3. Where did the mummy of Tutankhamun come from, and how did he die? The discovery of Tutankhamun's tomb in 1922 by Howard Carter was an unparalleled event. It was the only nearly intact royal tomb ever found in Egypt's Valley of the Kings, filled with incredible treasures. King Tut, a relatively minor pharaoh who ruled around 1332 to 1323 BCE, became a global sensation. But despite the wealth of objects, many questions about the young king remained. Who were his parents? How long did he live? And most enduringly, how did he die at such a young age, around 19 years old? Was it murder, accident, or disease? For decades, scholars debated these points. Early examinations of his mummy were crude by today's standards, focusing on preserving the body rather than in-depth medical analysis. X-rays in the 1960s provided some initial clues, suggesting a blow to the head, but the evidence was inconclusive and often misinterpreted. The real breakthrough came with advanced medical imaging and DNA analysis in the 2000s. In 2005, a highly publicized CT scan project, led by Dr. Zahi Hawass, then Secretary General of Egypt's Supreme Council of Antiquities, involved a portable CT scanner brought directly into Tutankhamun's tomb. This allowed for detailed, non-invasive imaging of the mummy, generating over 1,700 high-resolution cross-sectional images. These CT scans ruled out the most popular murder theory, which was a blow to the head. They found no significant trauma to the skull that would have been fatal. However, the scans revealed a complicated medical history. Tutankhamun suffered from several ailments, a clubfoot, which would have required him to walk with a cane. Many canes were found in his tomb, a fractured left thigh bone, possibly sustained shortly before his death, and signs of malaria. The fracture was not healed, suggesting it happened close to his death and could have led to infection. This research was widely published in the Journal of the American Medical Association and in other scientific outlets. Then came the groundbreaking DNA analysis. Between 2007 and 2009, a large-scale DNA study was undertaken on Tutankhamun's mummy and other royal mummies from the 18th dynasty. Using highly sophisticated methods to extract and amplify ancient DNA from bone tissue, a team including Dr. Hawass and geneticists like Dr. Albert Zink, also involved in Ötzi research, established genetic relationships. This was incredibly challenging due to the degradation of ancient DNA and the risk of contamination. The DNA study, published in JAMA in 2010, provided definitive answers about his parentage. It confirmed that Tutankhamun's father was Akhenaten, the heretic pharaoh who introduced a monotheistic cult of the sun god Aten. And his mother was Akhenaten's sister, a mummy known only as the Younger Lady, KV35YL. This confirmed a pattern of incest within the royal family, which likely contributed to Tutankhamun's various congenital health issues, including his clubfoot and perhaps a compromised immune system. The DNA also found evidence of the malaria parasite Plasmodium falciparum in Tutankhamun's body. So, the leading theory for his death, synthesized from CT and DNA evidence, is that he likely died from a combination of factors: his inherited weaknesses from incest, a debilitating clubfoot, a sudden leg fracture that became infected, and a severe bout of malaria. It wasn't murder, it was a tragic, complex medical demise. But even with these profound insights, some questions persist. While we know the cause of death was complex, what was the exact sequence of events in his final days? Was the leg fracture an accident, or did it happen in battle or during a fall? Did he have siblings, and what happened to them? And beyond his biological story, what was the full political context of his reign and sudden death? He reversed his father's religious reforms. How much was his young age and illness influenced by the powerful priests and courtiers around him? The technology has brought him closer, but the full human drama of his life and short reign still has many unrevealed layers. Number 2. What was the lost city of Mahendraparvata, and what did it look like? For centuries, legends spoke of vast, ancient cities hidden beneath the jungles of Cambodia, part of the mighty Khmer Empire that built Angkor Wat. Archaeologists knew Angkor Wat was just one piece of a much larger network, but the dense jungle canopy made traditional ground-based exploration incredibly difficult. Mapping the full extent of the Khmer capital region was a monumental task, and the idea of a major lost city hiding nearby seemed almost impossible. Specifically, there were ancient inscriptions that mentioned a mountain city called Mahendraparvata, believed to be the first capital of the Khmer Empire, founded in 802 CE. But its location remained elusive, swallowed by the jungle. The traditional methods of archaeology involving walking through thick jungle and digging could only ever uncover small, isolated parts of such a vast, overgrown landscape. The sheer scale and density of the vegetation prevented any comprehensive survey. The game changer was LIDAR, light detection, and ranging technology. In 2012, a team led by Australian archaeologist Dr. Damien Evans, working with the French Institute of Asian Studies and Cambodia's Apsara Authority, mounted a LIDAR scanner on a helicopter. The LIDAR uses laser pulses to measure distances. When fired at the ground from an aircraft, these pulses penetrate the jungle canopy and bounce back, creating incredibly detailed 3D maps of the terrain beneath. It can literally strip away the vegetation, revealing structures, roads, and agricultural features that have been hidden for over 1,000 years. The results, published in journals like Proceedings of the National Academy of Sciences PNAS and widely reported in National Geographic, were stunning. The LiDAR survey revealed an expansive, previously unknown city spreading across Panam Kulen Mountain near Angkor Wat. This was Mahendra Parvata. It was not a small settlement, but a large urban center covering an area of 40 to 50 square kilometers, with an intricate network of temples, reservoirs, roads, and even a sophisticated hydraulic system of canals and embankments for water management. The LiDAR imagery showed the precise layout of the city, its grid patterns, and the location of individual structures, allowing archaeologists to selectively target areas for ground excavation. This was archaeology on a completely different scale. It revealed that the Khmer Empire was even more extensive and complex than previously imagined, with a history that began on Phnom Kulen before shifting to Angkor. This discovery significantly pushed back our understanding of Khmer urban planning and engineering. Further LiDAR surveys in 2015 and 2016 expanded on these findings, revealing more cities, reservoirs, and interconnected networks across the greater Angkor region, showing it was perhaps the largest pre-industrial city on Earth. Dr. Evans's work has transformed how we view the Khmer Empire, demonstrating the power of remote sensing and uncovering hidden civilizations. This technology allows archaeologists to see archaeological sites that are completely invisible from the ground, offering a comprehensive landscape-level view before a single shovel enters the earth. It provides a blueprint for future targeted excavations, making the research much more efficient and effective. But even with this incredible technological peak beneath the canopy, many questions about Mahendra Parvata remain. Why did the Khmer Empire eventually shift its capital from this mountain city to Angkor? Was it due to water management issues, political changes, or defensive strategies? What were the specific ritual and political functions of the temples within Mahendra Parvata itself? And what was daily life like for the people in this massive early Khmer capital? We have the layout, but the stories of its inhabitants, their beliefs, and their eventual migration are still largely unwritten, waiting for the patient work of archaeologists to bring them to light. Number 1. What was the language of the Rosetta Stone, and what did it say? The Rosetta Stone is perhaps one of the most famous archaeological artifacts in the world, and for a long time, it was one of history's greatest linguistic puzzles. Discovered in 1799 by French soldiers in Egypt, it was a dark granite slab inscribed with 3 different scripts. One was Ancient Greek, the other 2 were Egyptian hieroglyphic, the formal pictographic script, and Demotic, a later cursive Egyptian script. The critical insight was that the text was identical in all 3. This was a decree issued by King Ptolemy V in 196 BCE. But for centuries, no one had been able to read Egyptian hieroglyphs. They were a lost language, a beautiful but indecipherable code. The discovery of the Rosetta Stone offered a potential key. For decades, scholars across Europe raced to crack the code. They understood the Greek text, so they knew what the decree said. The challenge was to match the unknown Egyptian scripts to the known Greek. It wasn't just about matching words, it was about understanding the entire language system. Was hieroglyphic a purely symbolic language, or did it represent sounds? The breakthrough wasn't a single technology in the modern sense, but rather a sophisticated methodology of comparative linguistics and cryptology, aided by increasingly precise tools for transcribing and analyzing the inscriptions. This was intellectual technology, a system of thought and analysis that could be applied. The key figures in this race were Thomas Young, an English polymath, and Jean-François Champollion, a brilliant French philologist. Young made important initial progress by correctly identifying some phonetic values in the Demotic and hieroglyphic texts, particularly the names of Ptolemy and Cleopatra, which were enclosed in Cartouche's oval rings. He published his findings, showing that the hieroglyphs weren't just symbols but also had phonetic components. But it was Champollion, with his deep knowledge of Coptic, a late form of the Egyptian language written in Greek script, still used in the Coptic Church, who finally cracked the full system. He reasoned that Coptic, despite being much later, retained many elements of ancient Egyptian. He meticulously compared the Greek names and words with the hieroglyphic and Demotic versions on the Rosetta Stone, identifying individual hieroglyphs that represented specific sounds. He used a methodology of systematic comparison and hypothesis testing. For example, he figured out that the hieroglyph for lion could also represent the sound of all. His groundbreaking letter to M. Desir in 1822 and later his Presto System Hieroglyphique in 1824 laid out the complete decipherment. He showed that hieroglyphs were a complex system combining phonetic signs, ideograms representing ideas, and determinatives to clarify meaning. This was a monumental intellectual achievement. The technology involved was painstaking, detailed textual analysis using precise copies of the inscriptions, often made using rubbings or plaster casts for accurate reproduction of the characters, and comparative linguistic tables. It was about systematic data processing by the human mind, enabled by access to accurate source material. The Rosetta Stone wasn't just a text, it was a cryptographic key, and Champollion developed the algorithm to unlock it. With the Rosetta Stone deciphered, the entire wealth of ancient Egyptian written history, previously locked away, suddenly became accessible. Thousands of inscriptions on tombs, temples, and papyri could now be read. We learned about pharaohs, their conquests, their religious beliefs, their daily lives, and their administrative systems. It opened up an entire civilization to modern understanding, but even with this monumental decipherment, some questions persist. While we can read the words, fully understanding the nuances of ancient Egyptian thought and culture, its poetry, its specific jokes or metaphors, is still a challenge. How much of the ancient Egyptian language's pronunciation has been accurately reconstructed? While we know the phonetic values, the exact vocalization is still debated. And what other lost languages, perhaps even more ancient, might also be unlocked if we could find their own? Rosetta Stones. There are still many ancient scripts, like the Linear A from Minoan Crete or the Indus Valley script, that remain undeciphered, waiting for their own Champollions and their own technological breakthroughs.